We okay? Ready to go? Okay. I was introduced earlier by accident because I sat in on the panel. But just to remind you, I'm head of digital architecture at London North East Railway. And also I'm a consultant architect on the Great British Railways developments. So I'm looking at retail with that. So what the new retail architecture might be for everybody who uses a train. That's quite a role, that is. And Chris asked me to chair this afternoon because he's had me speaking a couple of times recently and knows I can do it, so I'm told. So this afternoon, what we've got are, in a moment, three talks. Stefan from Shutterstock, Kate from Secret Escapes, and Shubham from Whatfix. Okay? Then we take a coffee break. So the coffee break's at 14:55. And then at 15:25, we have a panel. And that panel will be moderated by myself. It will have Stefan and Kate on it. But unfortunately, Morgan's had to pull out due to some operational things. Morgan from the Navy. So he's been ordered something else, okay? I'm told you can't disobey orders in the Navy. Just to get on the stage in London. And then at 16:10, we have Serhi from LX. Have I pronounced that correctly? Thank you. Talking about hyper-automation. So, first and foremost, I'll introduce you to Stefan Britton, Senior Director, Enterprise Innovation at Shutterstock. And according to this, he's diving deeper into generative AI.
Yeah, good afternoon, everyone. Thanks for coming. And what I want to talk to you about today really is not just talk about generative AI in its traditional sense, about how you can use it in your business and what it does, but I actually want to break down how it works in a little bit more detail so that you can actually really understand the dangers that we're talking about for AI. And clearly, we'll talk about AI. It's a huge thing, and we may think, some of us, that it's really just blown up in the last sort of 3 years. But it hasn't. I've been working in AI for nearly 15 years, and the reason it feels like it's exploded now is because three things came together at the same time. So that was all the data that lives on the internet. It was the accessibility of the tech that we've got in our hands, as far as the iPads, iPhones, laptops, etc., and open source technology. So now, all of a sudden, all these things came together and exploded, and that's why AI is exploding, and it feels like it's become something today, but it's been under the horizon for a while. So I started out the year talking on behalf of Shutterstock about generative AI. A lot of people don't know this, but Shutterstock built DALL-E in partnership with OpenAI, and I was very heavily involved in that, and I'm going to talk about that in a bit more detail. We also partnered with a lot of the major AI players, so we've worked with OpenAI, obviously, as I talked about, but Meta, LG, Samsung built some incredible applications. I'm going to talk about those in a bit more detail. But first, I just want to point out, there's been a lot of talk about whether this is art, whether this is owned by whatever, and I'm going to dig into some of the copyright issues, but really I want you guys to start thinking now about this as a warning. And I'm going to break down now why this should be a real warning sign and a call to action for our entire industry. There's a lot of fears about artificial intelligence. There's a lot of fears about generative. But it's an opportunity, of course, and we've seen with technology before, when it comes out, it always disrupts and it always does a lot of things. And I've been very heavily involved in a lot of new products and a lot of startups. I've had 3 AI startups that I've exited. One of them we sold to Shutterstock, which is why I ended up there. And I guess, quick show of hands, does anyone think when I say Shutterstock of cutting-edge artificial intelligence applications? No. Probably not. And that's fine. But Shutterstock does a huge amount of artificial intelligence. So we get something like 250,000 images a day uploaded to the Shutterstock platform. So those images have to be checked for quality. They have to be checked for the styles. They have to be checked for what's in them. They have to have labels. They have to have descriptions. So, of course, only AI can check that many images in that amount of time. But Shutterstock have also acquired a number of AI technologies. And this one was the technology they acquired that I was working in, a company called DataSign. We built technology that was able to predict the performance of ads before you place them, particularly social ads, so things like Facebook. It's quite crazy when you think about advertising. $4 billion a year spent on advertising. Can any one of you remember the last ad you saw on TV? The last banner ad? The last pop-up on your phone? The last radio ad? The last billboard you drove by? Anyone remember anything?
Yeah, Doc Martens.
You've ruined my point. Well, one person remembers that one ad, but do you remember when you saw it, or did you just like it?
No, it was on Facebook, because they keep sending
Right, shut up, you've ruined my whole point now. But 4 billion should give us more than just one person remembering one ad, right? So that's the whole point. So what we did, we built technology, we linked into Facebook, we were able to analyze all the live ads that were happening at any one time, and then we could break those images down into several layers using computer vision, and then analyze the elements of the images and see what is in high-performing ads and what's in low-performing ads. And that meant that you could come on and you could test an ad before you run it. And that's actually really, really important, because the whole concept of A/B testing is clearly flawed. You only know something doesn't work after it hasn't worked, after you've spent money on it, after you've put it in the real world, you've run the ad. So with this world, we can tell you in advance, that image will work better in France, that image will work better in India, that image won't work at all, don't bother using it. So that was how I started out with Shutterstock. And it's a really important problem to solve, and we still need solving, because apart from the 4 billion, we as a society see more ads now than at any point in human history. The average person in Europe sees 11,000 ads a day, or you're exposed to 11,000 ads a day across various platforms. And because of this exposure, our attention spans are also dropping. So Facebook say it takes 50 seconds, Google say it takes 50 seconds, or 50 milliseconds for someone to decide if they like an image. Facebook say if you like an image on an ad, you'll dwell on it for 1.7 seconds before you click. Facebook also say they've got 9 million active advertisers at any one time. And they say that 60% of the click on your ad comes from the image you choose. So you put those numbers together, it means you've got 50 milliseconds to get 1.7 seconds attention from someone that's seen 11,000 ads from 9 million people just on Facebook alone, and it's your creative that has to do it, because your creative is clearly and statistically the single most important part of your ad, giving you 60% of the click. And right now, most people in marketing are just guessing the image they use, which is crazy. So AI is very, very good at breaking things down and allowing for prediction. AI has not often been used in creative space. And when I joined Shutterstock, one of the things that we wanted to do, working with OpenAI, was reimagine how that generative landscape could work. And my background, as I mentioned, has been in AI startups, but my actual educational background is in AI ethics. So as well as having grown a number of AI startups, I've exited 3 now, I also write ethical programs and governance programs for companies that are looking to launch AI products and services. So when I joined Shutterstock, what I wanted to do was make sure that we had some very clear ethical standards before we built something as disruptive as generative. So when we started building DALL-E, I knew the impact it would have on the creative industry. The board weren't quite so sure, but my colleagues at OpenAI were. We knew what we were doing, so we needed to make sure that we had ethics underpinning everything we did, because we knew we were about to build something that could be really disruptive. But we've seen this before, particularly in the creative world. We have seen before what happens when new technology comes out. 3 things tend to happen. So you get disruption, you get democratization, because everyone's now got access to this new tool set, but then you often get a creative revolution, or you get some kind of response. And if we look at these big inventions that happened over society, the printing press. When the printing press first came out, people said it was going to end literacy, because now the poor would be able to have access to books, which meant that it would ruin intelligence. Of course, that didn't happen. The printing press went on and caused the Reformation, the Renaissance. It directly caused the American and French revolutions. It gave us literacy and printing materials all around the world. It changed society. The record player, or the phonograph in those days, was going to kill live music. The same with the radio. But the radio saved thousands of lives all around the world. It meant that we could get news within 24 hours for the first time. It shrunk the globe. And far from killing the music industry, when you put the record player and the radio together, you've actually invented the music business. So this is what happens. When we create these bits of technology and put them in the hands of creatives then take that technology and do more with it. And what we've done with generative and the tools that are out there today effectively is raise the floor. So we've raised the floor now, because it means that people have got access to technology, they don't have to have a learning curve, the average person can do things that only a year ago an expert had to do. But what we haven't done is lowered the ceiling. So everybody, the whole industry, can go up and do more. Every industry is terrified of innovation when it comes out, and particularly technology when it comes out, and nothing more so than this, the camera. When the camera first came out, the art world was horrified. There was an artist at the time called Paul Delaroche that said painting is dead when he saw the first photograph. But in actual fact, rather than killing art, cameras actually became part of the artistic process. So painters started taking photographs and then using those to help them for ideation, and we see that now with the generative world. And not only that, but it also inspired artistic movements in itself. So the whole expressionist movement came as a direct result of the camera. The expressionist movement is all about trying to capture the romance or the essence of an image, and that was an exact juxtaposition against the scientific nature of the camera capturing every single thing. But from the minute we've been able to capture images, we've tried to manipulate them, and we've needed to control the narrative with these images, because images have the power to change the world. Anyone guess who that is? I think we probably all know, right? Abraham Lincoln. The year is 1860. Abraham Lincoln has got some really big plans. He wants to end slavery in America. He wants to create a union. He wants to change the world. But he's got a reputation of being too ugly to be American president. I know, a bit of a low bar, an American presidency. You can add in your own jokes there about where they've got to today, but this man was seen to be too much of a freak, quote unquote, to be American president. So he went to go and see someone called Matthew Brady, who's in New York. Matthew Brady was seen as a little bit of a charlatan at the time because he used ways of actually manipulating images. So here what we've got is arguably some special effects. What we've got here is he told Abe to bend his fingers so his fingers didn't look quite so long. He shone a really bright light in his face so it would shorten the attraction on the chest, so it wouldn't stand out quite so much. And my favourite piece, that's a fake Harry Hill-style oversized collar to try and make his neck look like it was a more balanced look. Now, this seems like it's innocuous, but he said it was this photograph that got him the Republican nomination. It was this photograph that enabled him to get elected. This photograph ended slavery and changed the world. That's how important photography is. It's the only medium in the world that can do this that quickly. Now, it didn't end there with the special tricks. This here was a picture that was released after Abraham Lincoln's death. Obviously, he was assassinated. People weren't planning ahead for that. There weren't lots and lots of pictures of Abe Lincoln looking like a statesman. So this is possibly, bear with me with my words here, but arguably the world's first photoshopped, quote-unquote, image, because that's the original. So what we've done in the first image, we're trying to impact the image at source while we're taking it. Here, we've got an engraver that's actually cut the head off of Abe Lincoln and put him on this body. And they've done a couple of other bits too. So this was a chap called Calhoun. He was pro-slavery. If you can see in the background here, this is actually titled here, An Argument for the Benefit of Slaves. So this man was all about keeping that. Obviously, this man was not. Here, this is now the Proclamation of Freedom. So they changed what was on the charter, and they swapped the heads. So here we've gone from sort of manipulating the image when it's taken to now actually carving out sort of gravings to be able to get on top of things. This is a man called Frank Hurley. Frank Hurley was one of the early originators of colour photography. So these are real original colour photographs. These photographs were taken on Ernest Shackleton's expedition to the South Pole on the Endurance. It's a bit of an excuse for me to talk about Shackleton. Shackleton's my personal hero. If you don't know the story, read the book Endurance. Incredible. They took a boat down to the South Pole. It got caught in the ice. It got crushed, and they all lived on an iceberg for about a year and a half and floated around the South Atlantic. It's incredible. But he took these photographs, but he also took this photograph, which is a really famous and important photograph from World War I. Now, interestingly, this was used both as a pro-war image, but also as an anti-war image. So this was the first exposure the British public had had to World War I. Now, this, again, is trickery. See, what we've seen before is we've seen engravings being edited, we've seen bright lights to try and make pictures. Here, Frank Hurley started to experiment with glass plates. So this is actually 3 photographs sewn into one. So if I show you where they are, it's pretty obvious. So you've got one image here. This is one picture of a battle. And this is another picture of a battle. And when I explain that, it's pretty obvious, right? Why would you put one trench right in front of another? And then, of course, the third photo is the aerial battle above. But he used glass plates to try and manipulate and create this picture. So we've been trying to manipulate images ever since we've been able to capture them. And whether we know it or not, photographers have been using artificial intelligence in post-production for the last 30 years. If you've ever used Photoshop, most of the tools that you're using there are powered with computer vision. So the most obvious one, the Magic Wand tool, click and paste, click and cut, all of that, it's using object recognition, computer vision. If you're using the technology that changes red eyes, it's using computer vision to be able to look at the face and recognize it's a face and then analyze and change the colors. So we've been using artificial intelligence for a long time. So from being able to manipulate images with copper, then with glass, Actually, now what we're able to do with Photoshop is manipulate pixels on digital images. So now we're in a world where we can manipulate pixels. It's not too much of a leap to being able to generate those pixels. So what I'm going to do now is I'm going to give you a little bit of a brief breakdown in how computer vision models are trained. Because I think once you understand this, a lot of the things that you're hearing in the public domain right now about copyright law, around scraping data, around biased data, et cetera, will make a lot more sense. So, hands up. Anyone want to guess what that is on the far left? My far left, you're right. It's Abraham Lincoln. Yes, thank you. Now, the fact that you knew that is actually pretty incredible, considering how pixelated it is. The fact that you knew it was a human face is one thing, but to know it's Abraham Lincoln, if you actually look at it again, it's just a few pixelated black and white pixels. So it's really incredible that we as humans can do that. But that's because we as humans have had millions of years of evolution to be able to recognize patterns, and particularly that one, the face and the head. It's the very first thing in the military we're taught to change from a camouflage point of view. We have to break up the shape of our head and our shoulders. It's the reason why when you're sat in traffic, you can tell if someone's looking at you, that peripheral vision. When babies are born, they only have two natural fears: loud noises and heights. They've done those experiments. So we obviously inherit some synaptic pathway to understand what height looks like. But computers, of course, do not. We have to force feed them and train them how to see. And this is how we do it. So this is a digital image of Abe Lincoln. And in every single pixel, there is data. Typically the RGB data, the red, green, blue data. So the color code is embedded in every single pixel. And what computer vision does is it analyzes those pixels, and then it applies a set of rules to determine what it believes it's looking at. And how does it understand those rules? Well, we have to train it. So this is how you train a computer vision model to recognize a cat. You have to show it lots and lots of pictures of cats, and then you have to make it guess, is this a cat, is this not? And eventually, it will get it right. And what happens is, every time you give it a chance to get it right, it's going to guess. If it gets it right, it then almost, again, go with me with this analogy, says to itself, oh, okay, well, my decision tree was right there, my thinking was correct. I'm going to remember that and embed that into my model. Or, when they put up a picture of a cat and they say, oh, no, sorry, you got that wrong, the computer will think to itself, oh, well, my thinking was a bit wrong on that, okay, so I'm going to readjust the model. And you just keep doing that over and over. And if we want to train a model on what cat looks like, we have to show it thousands and thousands and thousands of cats in every different type, every different style, in every different scenario, so it knows what cats look like. So this is what we call reinforcement learning, because, of course, we're reinforcing the decision-making that the models are doing. Now, this is great, and it works really well. So now we've got to a point where we've got a model that can recognize cats. So we say, hey, what is this? It's a cat. Brilliant. It gets it right most of the time. But if we flip it around and say, OK, well, you know what a cat looks like, so now I want you to generate one for me, that's what it's now going to be able to do. It's going to be able to actually generate a picture of a cat. Now, this is where prompting comes in, because if you actually start to put in things like, can you draw a picture of a cat on a bike, it needs to interpret what you're looking for. But it can only create images that it's been trained on. So this is where I say artificial intelligence has no imagination, because it can only replicate things that it's been trained on. It's not going to imagine something to begin with. If we've never shown our classification model a picture of a pig, if we've never trained it to see what pigs look like, when I ask it to draw a picture of a pig, or even classify a pig, it's not going to have a clue, because it's never seen a pig before. So to build these generative models, we need huge data sets. And that is why you hear now of these big companies going out there scraping data, like these big industrial trawlers, literally trying to scrape in as much content as they can, because if their model hasn't seen a pig or a goat or a blue car, their model can't draw those things. So that's why you're seeing this information get scraped and put in. Now, this is what we worked on with DALL-E 2. DALL-E 2 was built using predominantly Shutterstock licensed content, which meant Shutterstock was then able to do a number of things, which I'm going to come on to now. But underpinning all of this was what I mentioned at the very beginning: ethics. We had to be able to build something knowing we had an ethical framework that could guide the decisions we had to make, that we knew would change the industry and perhaps the creative world at large. Number one rule: artist protection. So this was ethics rule number one for us, making sure that we always had artist protection at the very center of everything we did. And I really pushed this because in the early 2000s, I was living with a very famous musician who lost control of his artist label, who lost control of all his art because everything went on Spotify, everything went online, and it was a real nightmare. He lost all of his control. And what actually happened was the record labels didn't work with the tech providers. They didn't want to engage with them, so it left a massive gap. And then Napster stepped in, if you any remember that, and basically the cat was out the bag then. So these musicians lost control of their music, they lost their negotiating place at the table, and now today they still don't earn what they used to. They have to go and make that money from doing tours and selling merchandise. So there's a lot of things that we have to get right here. So when it comes to actually looking at an image, we need to think about who's the originator. Well, in that training data, there was no image of a flaming bison, so we had to train it on all the content that was in the Shutterstock library. So we built a licensing fund, a commercial licensing fund, so any person who had content in that library was able to get paid out. So if you go on the Shutterstock tool now and you generate an image, you can have a license, you can use that image publicly, and the artist whose content was used get paid. And that's why you can get a license. Not many people doing that. We were the only people in the world doing it when we started. Adobe have started now. So that's point number one. And I'm going quick because I haven't got long left, and this is where it gets really important. So this is how we took care of artists, and that's great. That's what Shutterstock must do. This is the warning call that I need all of you to take care of, to notice, right? And this is what I'm going out talking to companies about as an ethicist and knowing this is what the danger of AI is. People think the danger of artificial intelligence, it's going to become a killer robot or it's going to become a Terminator. That's not what you need to worry about. What scares me about artificial intelligence is it becoming a racist old man making decisions in the dark with no oversight. And that can really happen very easily because, remember how I said how people are scraping data to build these models? Let's assume you want to train your model on what wealthy people look like. So I went on Google and I typed in wealthy people. That's what I got. Does that look representative? Does that look like the world? Is that what you want an AI model to think wealthy people look like? It's the same with any denominated element of society. So you do the same with old people. It's always infirm, old, sick people. Gay people, always overly sexualized, always loads and loads of rainbow photographs. There's more to being gay than this. It isn't just around men with beards kissing with rainbow flags, but this is always what you see. So again, if you're training a model on this, this is what it's going to put back out. Now, I'm going to go quickly because I've got time issues, but we've already seen in New York a big building that had a video entry system with computer vision. As a white man, a white middle-aged man, I would get into my apartment every single time I got home from work, 100% of the time. If I was a black man, I would get into my apartment 8 out of 10 times. If I was a black woman, I would get into my apartment 6 out of 10 times. If I was a Native American woman, I would be let into my own apartment once every 14 attempts. So that's effectively once every 2 weeks I get home from work, my video recognition system lets me in my own apartment. That's because the training data is bad. And we see it now with the racial bias in data because you go to DALL-E or any of these tools, and most of them now have fixed this, but at the beginning, if you typed in doctor, middle-aged white man, lawyer, middle-aged white man, superhero, middle-aged white man, that's all it kept kicking out with all these things, and I could go on and go on. But what's really scary is when you start to see the tools that are being built now with these models. Because what we're seeing in the world now is a lot of the AI tools are actually wrappers sat on top of these LLMs or these ChatGPT tools, open source tools. So one in particular, this young lady, she uploaded this photograph of herself with the prompt, give the girl from the original photograph a professional LinkedIn profile photo. Anybody want to guess what happened? Yeah, it's bad. Blue eyes and white skin. Yeah. That's what's happening. Now, that's what's happening today. And the reason I want to tell you this is because it's really easy to see what happens when you have biased data when you're looking at a generative tool. But we're not just talking about generative tools. We are also building algorithms that will determine who gets a place at university, who gets social benefits, who gets housing, who gets social security. We're building algorithms that determine which route the ambulance takes. And if an ambulance gets a call from 2 people at the same time, the AI decides where the ambulance goes. Now, do you want your AI making those decisions based on that kind of data, when it thinks that's what wealthy people look like, and that's what it thinks doctors look like? No. So the answer to this is ethics. We have to have ethical frameworks to determine how we build these tools, and we have to have visibility in how they're built. Now, there's always going to be a level of opaqueness because AI is a black box solution. It doesn't tell us how it comes to the conclusions. And what you need to think about AI is you don't program AI, you grow it. You give it a goal, you feed it data, and it finds its own way there. So we have to be custodians. We are looking at AI as a child. So we have to have rules of the house. So as I said, artist protection was our first one. Data audit. We ensured before we trained any data in any tool that it was checked for bias. We checked the labels for accuracy. If you think of our model of the cat, if I said there's 1,000 pictures of a cat and actually there's 500 of them are actually dogs because they're mislabeled, my model won't work. If I say here's 1,000 pictures of a cat and they're not labeled properly, my model won't work. So data audit. We also had to ensure when we looked at the racial profile and the male-female balance, we balanced it out because we were over-indexed. We had way more white people in our library set than we had Native American women because that's just what was on the Shutterstock library. So we had to clean that. Transparency and accountability. Again, you can't be too transparent with the models, but you can be transparent with what you're building, how you're building it, and where you got your data. So you can say, okay, we've got the provenance for this data, and we've got the consent to use it. That's a really important part. And lastly, diversity. This is really important because we cannot build technology built on just the same people that are building it. So what we can't have is a society that's living off of AI that's been built by 4 white men in the lab. The people that build these models must reflect the society that these models will be used in. Now, I've been doing this speech for a while. I've been talking about AI for 10 years. I was telling people for the last 9, we need to put these rules in place to protect the future society. But guess what? That's now. We are the future society. These models are affecting us right now, today. So if you ever get the chance to encourage anyone from any kind of background, economic, racial, religious, anyone, we've all got unconscious biases, whether we know it or not, and we have to have an expressive and inclusive team to build the AI. Otherwise, we're just going to circle and circle and circle. And the problems you saw with the generative tools are going to be in those tools that determine who gets the ambulance, who gets housing benefit, who gets the university. So all of us must be sure when we talk to anyone in AI, where do you get your data? How do you train it? Tell me your ethics policy. And if they can't do that, don't do business with them because our future is at stake. Right, thank you very much.
We'll be able to ask Stefan questions on the panel a little bit later, but we started 5 minutes late, so I want to just sort of go straight in.